In this video, we will learn about Bayesian inference and how Thomas Bayes' ideas can provide us with a model for how human cognition works. We will also discuss how it can go wrong. We will use the probability of flying pigs as our example throughout. Before we dive in, let's talk about what is Bayesian inference. Oftentimes we want to know about something that has a degree of uncertainty. For example, whether it is going to rain tomorrow, whether a flight will be delayed, or whether pigs can fly. Bayesian inference provides us with a technique for making best guesses. At this point, let's meet Mr. Stick. His friend told him that some pigs can fly, but he has never seen one before, so he is skeptical. His past experience and observations forms a world model in his head about how the world works. One day he comes across a hole in the wall, takes a peek and sees the face of a pig on the other side. He is wondering whether this pig is one of those that can fly. He is going to make his best guess in the style of Thomas Bayes. Who is Thomas Bayes? He is a mathematician and philosopher from the 1700s. He came up with a simple idea called the Bayes theorem. The core idea is this: you believe the probability of raining tomorrow is 50%. However, now you see a dark cloud in the sky. So your original estimate of 50% might be low. Given your new information, you might change the question to, if the sky has dark clouds, what is the probability of rain? And the answer to that might be 80%. We will talk about this in more detail later on in the video. Mr. Stick's belief, or world model if you like, tells him that pigs cannot fly, because he has never in his life seen a pig fly. However, to do things in Bayes' style, he needs to turn his beliefs into a probability. He doesn't believe that pigs can fly. So, should he set the probability to 0 or to something very low, but still has a remote possibility, like 1 in a million? That would equate to a probability of 0.000001%. Mr. Stick is smart. He remembers what a wise man Mark Twain once said: "It ain't what you don't know that gets you in trouble. It's what you know for sure that just ain't so." So he decides, even though he has never seen a pig fly, he's still going to leave his mind open to the possibility that there is a very small chance that the pig he saw might be able to fly. The next day, he walks past the hole again. He takes a peek and he sees the same pig, but this time, the pig has his back to him. Mr. Stick sees that the pig has wings. He knows that all pigs that can fly must have wings, so he is tempted to jump to the conclusion that he just saw one of those pigs that can fly. But wait, before he saw the wings, he believed that the pig he saw had a 1 to a million chance of being able to fly. Probability that this pig can fly is 0.000001%. However, now that he saw that the pig has wings, his old beliefs probably need to be updated. He was tempted to conclude that the pig must be able to fly, given that he saw the wings, and update his belief to 100%. He now remembers that he is supposed to be making a best guess in the style of Bayes. He decides that he needs to find out the probability that this pig can fly, given that it has wings. We call this a conditional probability. What is the probability that pigs can fly, conditioned on the new observations that Mr. Stick has made? According to Bayes' theorem, this is how we can calculate the new belief. There are many videos on the web that shows how he derived this, so we won't repeat it here. To calculate the probability that the pig can fly conditioned on the new observation, you need take your original belief. The probability that pigs can fly, shown here on the right by p fly, then multiply that by the probability of the observation among pigs that can fly. Then divide by the probability of the observation. This may sound abstract. Don't worry, we will come to that shortly. Let me just introduce some terminology here. On the far right side of the page is the existing belief, also called a prior. This is Mr. Stick's belief that there is 1 in a million chance that the pig he saw can fly. He made this before he saw the wings. On the left side of the equation is the probability the pig he saw can fly conditioned on the observations. This is called the updated belief, or the posterior. You can see that this equation in broad strokes is a way for humans to change their world model based on new information that they receive, such that the old belief is updated to a new belief, taking into consideration this new information. Let's say Mr. Stick observed that the pig has wings. Now, to use the Bayes theorem, we need additional 2 pieces of information. What is the probability that pigs have wings, and what is the probability that pigs have wings among pigs that can fly? More formally, the probability that pigs have wings conditioned on pigs that can fly. To estimate those 2 pieces of information, Mr. Stick needs to rely on his world model. Out of a million pigs, he believes that only 1 can fly, and all pigs that can fly have wings. For all the rest of the pigs that cannot fly, he discovered that some also have wings. There is a genetic mutation that causes 1 out of every 100,000 pigs who cannot fly to grow wings, so out of the 999,999 pigs that cannot fly here, 9 of them will have this mutation. The probability that a pig will have wings given that it can fly is 100%. The probability that a pig has wings, if you don't know anything about whether it can fly or not, is the sum of all pigs that have wings on this diagram divided by 1,000,000. That is the 1 pig that can fly that has wings, and also the 9 that has wings but cannot fly. So as you can see here, just because a pig has wings doesn't automatically mean that it can fly. If we plug those numbers in the yellow box, end up with 100,000. So given that Mr. Stick saw this pig has wings, according to Bayes, he should update his prior belief by multiplying by 100,000. His previous belief was 1 in 1,000,000. The new updated belief, or the posterior, is now 10%. The pig he saw has a 10% chance of being able to fly. This is a huge update to his prior belief based on his observations, but also quite different from his gut reaction after he saw the wings that the pig must be able to fly. Because Mr. Stick is able to update his world model, he is said to be cognitively flexible. But not everyone is like Mr. Stick. There are a number of places where humans often make mistakes. In the last section of this video, we discuss 3 common cognitive glitches. The first potential glitch is the one that Mr. Stick almost made. It is assuming that if all pigs that can fly have wings, and the likelihood of wings among pigs that cannot fly is extremely low, then all pigs that have wings must also be able to fly. As you can see from our example, there is only a 10% chance that pigs with wings can fly. But if you hear about a pig that can fly, there is 100% chance that it also has wings. These conditional probabilities are not reversible. The second potential glitch is the existing belief. Recall in an earlier slide that Mr. Stick decided that although he has never seen a flying pig, he remembers what Mark Twain said, so he decided to leave open the possibility that flying pigs exist by setting the probability to 1 in 1,000,000 rather than 0%. By doing so, he left the door open for new observations to increase or decrease his belief. However, if he was really obstinate and believes firmly that because he has never seen a flying pig that means there is no possibility that it can exist, he might set that probability on the right side to 0. 0 multiplied by any factor is 0, so unless Mr. Stick is able to directly observe a flying pig and update his world model directly, there is no way for him to update his beliefs even if he sees 100 pigs with wings. The third glitch is to do with the big mismatch between the prior and the posterior due to the large update factor of 100,000. The fact that his existing world model had to be updated so much is destabilizing. It causes cognitive dissonance. When Mr. Stick experiences cognitive dissonance, he has a choice to make. Option 1 is that he accepts that his observation is true. He might seek out more data to verify it, then accept that his world model is wrong and agree to update it. So now his new world model is the posterior. This big update is painful for a lot of people. Oftentimes, people's beliefs are tied in with their identity, what they have said to their friends in the past, their ego. Maybe they have made decisions in the past based on that old belief. So it is hard to admit that one is wrong and should update. Option 2 involves throwing out the observation. Mr. Stick might try to find some explanation to reject the observation, such as, I wasn't wearing glasses that day, so maybe I didn't really see a pig with wings. In real life, much of our new observations and new data comes from secondary sources that are not directly observed. For example, from social media, reading newspapers, words of mouth, etc. So it's even easier to undermine the observation by attacking the source of the new data. Sometimes it is less painful to find all kinds of reasons to reject the new information, just so that we can keep our old beliefs, identity, ego, and rationale for all of our previous actions intact. Those who are able to choose option 1 are said to be cognitively flexible and have a high learning quotient. Those who often choose option 2, even in the light of solid new data, is said to be cognitively rigid and end up making poor decisions as their world model becomes increasingly out of date. With this framework of thinking about Bayesian cognition and failure modes, we can all be more cognizant of when we may be unwittingly jumping to conclusions, not leaving a small possibility that something we don't know or believe actually exists, or latching onto old beliefs despite being presented with new facts.